Fusion Mobile, quality e-learning experience on the go.
My dear rest, today we are handling projectiles. And in projectiles, we discuss projectiles as parameters and also their movement. The movement of projectiles is known as projectile motion. While projectiles are those things that you can project into thin air and they move on their own under the influence of gravity only. Example of projectiles: your javelin, stone projected from a catapult, a flying bullet, etc. Before we go into the topic, I would like you to take a little pause and write out for me 5 projectiles in sports world, 5 projectiles in daily life, and 5 projectiles as warfare. When you are through, join me now in the main topic. Projectile. A projectile is an object thrown into the air or launched into thin space, and it moves freely by itself under the influence of gravity and air resistance. In studying projectiles, there are basic parameters we must consider, which if we don't talk about them, then we cannot really make meaning of projectiles. But before then, let's make a dramatical expression of what we are doing. We'll say that a projectile, assuming this is my Cartesian, a projectile is a particle or an object projected into thin air, and it goes freely on its own and finally gets back here under the influence of gravity and air resistance only. This is the movement of a projectile, and we'll say that it moves in a parabolic path or elliptic. Parabolic here simply means just something like in a circular form, but it's not a complete circle. Maybe looking at the diagram, you can see it's a half a circle. But I want to bring something from this diagram. Do you notice that when this body is here, it has covered a horizontal distance and also has covered a vertical distance? And when it gets to this point, it has also covered a horizontal distance and also a vertical distance. So we'll say that in projectile, there are 2 independent motions. That is, vertical motion due to gravity. I hope you're writing it down. There are 2 independent motions. One, the vertical motion as a result of gravity. And the second one, the horizontal motion as a result of uniform velocity. These 2 motions are independent. Okay, from there we can now go into parameters of studying motion. The first one I want to mention is the time of ascent or time of descent. Time of ascent is the time taken, look my stroke, is the time taken to move from here, which is the point of origin, to here, which is the maximum height. Or the time taken to move from here, which is the maximum height, that is here, h, to this point, which is the point of landing. This one is called ascent, this particular one, while this one is called descent. The time of ascent or time of what? Descent. And mathematically, it is given as small letter t, which is equal to u sine theta all over g. This is time of ascent or descent, any day, anytime. But my dearest out there, you will bear me witness that the time of ascent is the same as the time of descent. If it takes 1 to move from this point to this point, it will also take 1 to move from this point to this point. That means 1 plus 1 will be equal to what? 2. So from there we now define the time of flight. Time of flight of a projectile is the time required for it to return to the same level from which it was projected. From this point, it will move all through the way it gets to this point. That means time of flight, capital letter T, is equal to small letter t, which is ascent, plus small letter t, which is descent. Bringing them together, we have t equal to 2 small letter t. That means t is equal to 2 outside. Now, instead of writing small letter t, I will replace it with u sine theta, and I hope I've not committed any crime. That means u sine theta all over g. So we'll say that time of flight is equal to 2u sine theta all over g. This is the equation of time of flight, while this is the equation of time of ascent or descent. From there we'll move to the next slide. Here we have the maximum height, which is simply the highest vertical distance or displacement reached as measured from the horizontal or the projection plane. Mathematically, it can be given as h equal to u squared sine squared theta all over 2g. I put it down. H equal to u squared sine squared theta all over 2g. If you find it difficult to write this, please write it this way. H equal to u squared sine theta all squared divided by 2g. Both will give you the same answer. While the range is defined as the horizontal distance from the point of projection to the point where the projectile hits the projection plane again. That means after the projectile have moved from the point of projection to the point of landing, the horizontal distance measured is what we call the range. And mathematically it is given as r equal to u squared sine 2 theta all over g. U squared sine 2 theta all over g. But if they ask you to calculate the maximum range, that is r maximum, that means we only get r maximum when theta is equal to 45 degrees, and 2 times 45 is 90. Sine 90 is 1. That means maximum range is u squared all over g. Now I would like us to take the summary of all the equations in projectile. First, we have the vertical component of velocity Vy, which is equal to u sine theta. Secondly, we have the horizontal component of velocity, Vx, which is equal to u cos theta. Then we have the time of ascent, which is t equal to u sine theta all over g. Then from there we can get the time of flight, t equal to 2u sine theta all over g. Then we have the maximum height, h equal to u squared sine squared theta, sine squared theta all over 2g, while range is equal to u squared sine 2 theta all over g. Then I add my own, which I call the UD's formula, which can help you to solve any projectile motion in half parabola. That says that t is equal to square root of 2h all over g. For example, you know that vertical motion is independent of the horizontal motion, but JAMB or WAEC can go crazy and ask you questions that combines two of them. They can ask you to calculate the range and they will give you the height. Do not panic. Just note that range is equal to ux times t, where ux is the horizontal velocity and t is the time. Here is either small t or capital letter T, depending on the time you have, whether it's time of ascent, half parabola, or time of flight, full parabola. So if such question comes up, they've given you h and they say calculate range, just use UD's formula here, 2h over g, to replace your t, and we have r to be equal to ux square root of 2h all over g. I would like you immediately to pick up your JAMB or WAEC past question, scrap out all questions in projectile and solve them now. And if you have any problem with anyone, don't hesitate to send your email to Fusion Mobile Nigeria or visit www.wunderbaik.com. The next topic we'll handle is the equilibrium of forces. But before we do that, don't hesitate to run back to what I just told you. Scrap out your questions now and see how able you can solve them. Thank you. See you in the next class.